Number 5, we need to, it says the candle is 4 inches tall and burns at a rate of 2 inches per hour. Write an equation to model the situation. So all we need to do is write an equation for this. I'm going to say H is the height of the candle, and T is the number of hours that the candle has been burning. So those are my two variables. So for my equation, I'm going to say H for the height of the candle. It says that it started at 4 inches tall and it's burning. So we're starting with 4 inches, like our y-intercept is 4, and it's burning, which means that it's getting shorter, so we're going to subtract. The slope is 2 inches per hour. Anytime you see something per something, that's usually your slope. So it's burning 2 inches per hour, so we're going to say minus 2, and T for number of hours there for my equation. And that's all I have to do in number 5. You could have different variables. For number 6, write an equation of a line in standard form that has a slope of -8 and a y-intercept of 4. Standard form is bolded here, so you remember that has to be in the form of ax plus by equals c. And a, b, and c all have to be whole numbers, and they have to be in that order. So currently they gave me the slope and they gave me the y-intercept. This is m and this is b. So what I'm going to do is I'm going to write it into slope-intercept form, which would be y equals mx plus b, so -8x plus b is 4. This is in slope-intercept form, but I need to go into standard form, which means that I need the x to be on the left side. To move the 8x to the left side, since it's negative, we would add 8x to both sides. Now we can write the 8x in the front and say 8x plus y equals 4. And this is the standard form on number 6. For problem number 7, we want slope-intercept form. That's highlighted. I'm going to make sure I know what form to be in. It says write an equation that is perpendicular. That is another thing that I need to make sure I'm aware of. Perpendicular to this line. One really great thing is that this line is in slope-intercept form. And the slope of this line is right here. The slope is 3. Since I need to be perpendicular to that, I'm going to go over here and I like to write this. This was the current slope. I'm going to draw an arrow and I like to put the symbol perpendicular above that. So that I remember this is the original and my new perpendicular slope is going to be over here. Perpendicular means that it's going to be the opposite reciprocal of the original. So we need the opposite sign, which that's positive, so this will be negative. And I'm going to flip-flop that. So it'll be 1 over 3. This is the new slope. So that's a slope that I'm going to use, and it has to pass through the point 0,4. Depending on if you notice that that is the y-intercept, you could do this and write it into slope-intercept form, which would be y equals -1/3 x plus 4. Of course, if you forget that and you're unsure if that's the y-intercept or not, or if they didn't give you the y-intercept, you can write it into point slope form, which would be y minus y1 equals m parentheses x minus x1. This is one that we use a lot in Algebra 2. So I'm going to set this up. It would be y minus the y value from this point is 4 equals the slope is -1/3. X minus the x value from that point is 0. Then you would just simplify that so that you'd have slope-intercept form. To simplify, we distribute this -1/3. -1/3 times x, -1/3 x. -1/3 times 0 is 0, so nothing would be there. Then we would just add 4. So we would get y equals -1/3 x plus 4. So you could work this either way. It all depends on if they gave you the y-intercept, of course, in the equation, and if you recognize that that is the y-intercept. But this is the perpendicular line.